Hi guys!
So we're going to be talking about the scary plus equals in computer programming. And to do so, we're going to have our math world.
And our computer world.
So let's start in math world. We're in our comfort zone. We like it, or we tolerate it the least. So when we have a change in position, we're going to have our final position, x sub f, equal to x sub I, our initial position, plus velocity in the x direction, v sub x, times delta t, or change in time. Now, forgive the words that are going to be just in front of our faces here as we're talking to you. But this statement is saying that our initial position plus velocity times time, which is going to be a distance again, because velocity is distance over time. So then if you multiply by time, it's just going to be a distance again. Now we have our final position by adding those two together. But in computer world, we have to do something different. We have to make ourselves a little bridge over, because we don't use delta t.
Instead, we use this strange thing, dt, because the triangle isn't really compatible with the way the computer thinks, and the computer's going to read, oh, triangle, so
what am I supposed to do with this?
triangle?
And also, I mean, we probably could find a way, but like, this is easier, and we're lazy, so let's do the easy thing.
So, to explain this to the computer, we're going to start out with this. Our final x equals our initial x plus this old vx asterisk dt, which is just the times. Now
And make sure your vx is not, that's not a subscript, that's a regular x there.
Yes. So, it's going to look more like this.
Because this way our computer can tell the difference between a vx and vy.
Now, but there's an even easier way for the computer to write this out and understand it as well. And this is this plus equals concept. So we're going to start out with our x plus equals our big vx times our dt.
And so what this is saying is that every single time we want to have our x, we're just going to add on to the old x. So we're going to add on to the initial x, our new vx times dt, to get our new final x here. And that way it's just updating location, and that's why we refer to it that way.
Yeah.
So if we're gonna have a similar concept when we talk about velocity. So we have our vx, we're gonna talk about the x direction here, just keep it same. We have our final velocity, v sub f, equal to our initial velocity, v sub I, plus a in the x direction, acceleration, times our delta t. And same way, acceleration is velocity over time, so if we multiply it by time, it turns back into velocity, and we'll get our final velocity there.
But now, if we go over the computer world, we can do the same thing, basically, that we did with the position. So we start off with our big vx, and now if we just hop right in there, we can get a plus equals this ax times dt. So, just like in math world, it's going to update based on the acceleration times the time, which gives us a velocity.
And that way we'll just keep updating and saves ourselves some steps, and now that you understand this, it'll hopefully go a little bit quicker, a little bit smoother.
Yep.
Alright.
Awesome.
Good luck, guys!